Hello students, the experiment that we are going to perform today is to find the thermal conductivity of a bad conductor using Lee's disk experiment. To start with, let's discuss the apparatus or the setup first. This is a steam generator. This is a hot plate with which we heat this steam generator to generate the steam. This is the steam chamber. Once the steam is generated in this steam generator chamber, with the help of these tubes, the steam is passed through this steam chamber. This is the metallic disc, and this is a cardboard sheet or a bad conductor material for which we are going to conduct the experiment, for which we are going to find the thermal conductivity. This is a stand. Additionally, we have two holes to insert the thermometer, one in the this metallic disc and one in this steam chamber. Now, to start with the experiment, this Lee's disc or this metallic disc, this bad conductor material or this bad conductor disc, and the steam chamber, all these are placed together in a sandwich form. Now, this is switched on so as to produce steam in this steam chamber with the help of this hot plate. The steam is, as I already discussed, the steam is passed through this steam chamber. This is the inlet for the steam chamber, and this one is the outlet for steam chamber. This is a thermometer, and we insert that thermometer in the Lee's disc or in the metallic disc. Second thermometer is to be inserted in this steam chamber. Now, we have to wait till the water is heated and steam is generated. Once it is the steam is generated and it is passed on through this chamber and it starts heating this Lee's disc, we will have to wait till the steady point is reached, after which there is no further increase in the temperature of this Lee's disc. We will have to wait till that point. So let's wait till it gets heated. Now the steam generator has started generating the steam. Initially, the temperature of Lee's disc or the metallic bottom disc is around 25-26 degrees Celsius. Let's wait till the steam is generated and it starts coming out from this side, that is from the outlet, and slowly and steadily the temperature of this Lee's disc starts rising. The steam is being generated, which is being passed on through this chamber. The chamber is getting heated with the help of steam, and the temperature is slowly and steadily rising. Now it has reached to around 62 degree C. And same way, the heat is being transferred or conducted through this bad conductor to the bottom metal disc or the Lee's disc, and in turn the temperature of this Lee's disc is also rising. It is now approximately 52 degrees C. Now let's wait till the steady state is reached, and after that there is no further increase in this Lee's disc in the temperature. The principle on which this experiment works is that conduction takes place only if there exists a temperature gradient in a solid or stationary fluid medium. Heat moves along a temperature gradient from an area of high temperature and higher molecular energy to the area of lower temperature or lower molecular energy. Conductive heat flow occurs in the direction of the decreasing temperature because higher temperature is associated with higher molecular energy. The transfer will continue until thermal equilibrium is reached. The rate at which heat is transferred is dependent upon the magnitude of temperature gradient and specific thermal resistance of the material. Thermal conductivity is quantified as the reciprocal of thermal resistivity, which measures the object's ability to resist heat transfer. Now, as we can see, the steam is coming out of the outlet chamber. The temperature of the steam chamber has risen to approximately 100 degrees C. And that of the lees disc or the metallic disc has risen to approximately 55 or 56 degrees C. Let's wait until the lees disc temperature reaches a steady state, after which there is no increase in it. Now, after around 35 or 40 minutes of heating, the temperature of lees disc has reached around 69 degrees C, and it is not rising any further. The temperature of the steam chamber is approximately 100 degrees C. Now, once the steady state is reached, what we have to do, we have to remove the bad conductor from the steam chamber as well as the lees disc, so that the lees disc and the steam chamber come in direct contact. Now, as you can see, the bad conductor has been removed, and the steam chamber and the lees disc are both in direct contact. Now, heat them such that the temperature of lees disc rises to 10 degrees more. That is, earlier, like theta 2 was around 69 degrees C. Now we have to heat it up till 79 degrees C. Now, as the temperature has risen to 79 degrees C, we would stop heating and we would remove the steel chamber from the lees disc and replace the bad conductor on the lees disc. Now, as the steam chamber has been removed and the temperature of lees disc is around 79 degrees C, now we would start the stopwatch and shall note down the temperature every 30 seconds. We have to take care that the bad conductor is now replaced on the lees disc. Now let's start taking the reading every 30 seconds. Like after 30 seconds, it is 78 degrees C. I shall note it down. After 60, it is approximately 77. After 90 seconds, it is 76. And so on. We shall note down the reading till theta 2, that is 69 degrees minus 10. That is, we shall note down the temperature till the temperature falls down till 59 degrees C. Once we have taken all the readings with a time gap of 30 seconds, from 0 to 1080 seconds, we have to plot a graph like this, taking time on x-axis and temperature on y-axis. Once we have made the graph, we have to draw a tangent, and then we have to calculate the rate of cooling, that is dt by d theta by dt. The rate of cooling comes out to be 0.025 per second. In my case, you can calculate your own. Once we have calculated the rate of cooling, then we have to use the formula K, that is for the thermal conductivity of the conductor that we are calculating. K is equal to m into S into D divided by pi r square into theta 1 minus theta 2 into d theta by dt. That was the rate of cooling that we have already calculated. Now m here is the mass of the metallic disc, that is 844 grams, or you can say 0.844 kg. S is the specific heat of steel that I have checked from the table. It is 0.12 kilocalories per kg degree C. D is the thickness of the bad conductor. This one, like this one. D is the thickness of the bad conductor that we have calculated with the screw gauge. It came out to be 194 mm, that is 0.00194 meters. Then pi is 3.142, and r is the radius of this disc. Radius, first we have to find out the diameter. Diameter was calculated with vernier calipers. It came out to be 11.16 centimeter, or we can say 0.1116 meters. So the radius was 0.0558 meters. Theta 1, as we already know, was 100 degrees C, and theta 2 was 69 degrees C. That was the steady temperature attained for the lease disc. So we have to substitute all these values in this formula, and we have to calculate the thermal conductivity of the bad conductor, that is the cardboard sheet that we had used. Thank you.